In a Korean restaurant, one of the popular dishes is of course the Korean stone pot rice, also known as dolsot bibimbap. The dish is served inside an extremely hot stone pot so that the food is kept warm while we eat it. Have you ever wondered how hot the pot is and how long it can keep the food warm? Well, to find out about it, the mad scientist, that's me, took a handheld thermometer into a Korean restaurant and ordered a dolsot bibimbap to do the investigation. When I did the experiment, the waitress was looking at me strange, but for the sake of science, I don't mind looking like I'm crazy. This is the actual data from the side of the stone pot that I measured. We can see that when the pot is served, the temperature of the pot is a whopping 240 degrees Celsius. Consider that it takes about 1 to 2 minutes to carry the pot from the kitchen to the table. The temperature of the pot on the stove in the kitchen is probably close to 300 degrees Celsius. It is even hotter than the oil that is used to make French fries. Of course, as time goes on, the temperature decreases, but even after 10 minutes, the pot temperature is still above 100 degrees Celsius, and it is still about 80 degrees Celsius after 20 minutes. The experiment ended after 25 minutes. That's because I'm happy and full. If you look carefully at the data, you will notice that there are two different time segments during the meal. The initial part of the temperature profile can be fitted with an exponential curve like this. But then after about 9 minutes, the coefficient of the exponential curve is changed. To explain this, let's try to see what is happening when the pot cools down. Since the pot is hot and the room temperature of the restaurant is about 25 degrees Celsius, there is heat loss from the pot to the surrounding. To predict the temperature of the pot with time, here let's first assume that the pot and the food are at the same temperature, and that the heat is lost only to convection. We can now write down the heat balance equation, where the change in temperature of the pot can be related to convection loss, where m is the mass of the bibimbap. Cp is its heat capacity, A is its surface area, and H is the convection heat transfer coefficient. To simplify the situation, let's further assume that the mass, heat capacity, surface area, convection coefficient, and room temperature are constants. By solving the differential equation, we get that the temperature is an exponential function with time, or if we look at the logarithm of the temperature, it will be linear with time. Here is the plot of the logarithm of temperature with respect to time. Indeed, the data is linear, but we see the two different slopes, where the temperature drop is faster at the beginning than at the end. So what is the reason for this? First of all, our model assumes that there is only loss from convection. In reality, there is also heat loss from radiation, which is larger at higher temperature. Second, convection coefficient for natural convection is not a constant, but is typically larger at higher temperature. Also, during the meal, I put in the delicious chili sauce into the pot at the beginning and mixed the food up, which probably decreased the temperature of the food as well. You may have also wondered why can the pot keep hot for so long? The secret is that it is very heavy, which makes the exponential term small. In fact, a typical stone pot weighs as much as 5 pounds, which is about 2.26 kilograms. Including the food, it will be close to 3 kilograms in weight. It will not work if the pot is any lighter. And to know that, the Korean waiters and waitresses have to routinely carry a 3 kilogram pot at 300 degrees Celsius from the kitchen to the table, that's amazing. Are you hungry now after watching the video? Go and try out a hot dolsot bibimbap in a Korean restaurant near you. Thank you for watching. Bye bye.